Okay, so today we're doing systems of inequalities. So we've been doing systems of equations, now we're going to take that into systems of inequalities. This is kind of fun, actually. It's a lot of graphing. I enjoy graphing systems of inequalities, but of course I enjoy a lot of weird math things, so I don't know if you will or not. Objectives are to identify whether a point is a solution for a two-variable inequality. So when we're solving equations, if we want to know if a point is a solution to the equation, what would we do to it? If we have like a point 2, 1, and we want to know if it's a solution to an equation, how do we know? Plug it in. We're going to be doing the same thing for inequalities. We're also going to talk today about graphing linear inequalities in two variables. Objectives 3 and 4 will wait till part 2 of this presentation. Okay, so an example, is the ordered pair 1, 2 a solution of y is greater than x minus 3? So we're going to solve this just like we do when we do equations. We're going to substitute the values in to check whether the equation is true. So our x value is 1, our y value is 2. So we have 2 is greater than 1 minus 3, which simplifies to 2 is greater than negative 2. Is that inequality true? Is 2 greater than negative 2? Good. So the answer is yes, it is a solution. Okay, now let's try negative 3, negative 7. We have negative 7 is greater than negative 3 minus 3. So negative 7 is greater than negative 6. Is that statement true?
No.
No. So this one is not a solution to that inequality. Okay, so you see what we're doing? We're just plugging the x and y in, or the x and y in the equation, or in the inequality, and then we're checking to see if it's true once we simplify it. So go ahead and try this one. We'll pause for a minute. Okay, Noah, did you find, is it a solution?
Yeah.
Yes, okay, tell me what you did to find that.
The y is 3. I got mixed up.
Okay, well, okay, so looking at it,
So
let's
the y
start.
is 6.
Y is 6, so we have 6 is less than or equal to 2/3 times 3 plus 4. Okay, so when we multiply this fraction times 3, the 3's are actually going to cancel out, and we end up with just 2 plus 4. 6 is less than or equal to 6. Is that true, Noah?
Yes.
Yes, so it is a solution. You're going to have a few of these to do in your textbook for homework. Some of these you can just kind of tell right away just from looking. Did everyone get that? Yeah.
Betcha.
Okay, now let's move on to graphing an inequality in two variables. This is just kind of the information page. We're not going to do any work on this. So we graphed inequalities before. We had inequalities and we graphed them on a number line. Do you remember doing that, where we put dots and arrows?
Yeah.
This is similar, but now we have two variables, so we have to use a coordinate system. So when we're graphing an inequality, we're going to graph the line. We're going to plot two different points, just like we do with linear equations. You're going to use your y-intercept and your slope to graph the line. And then here are the extra things that you need to know. If you have a less than or a greater than sign, you're going to use a dotted or a dashed line, a line that's not solid. And then if you have an equal sign, like less than or equal or greater than or equal, then you're going to use a solid line. It's kind of like when we did our work on the number line. Which one of these did we use a solid circle for, a dot for? Remember?
The one that was equal or equal to, yeah.
Yeah, the one that had equal. So this one would have had a closed circle, and this one would have had an open circle. It's the same idea. A dashed line means that we're not including any of the points on that line, just everything that's greater than or less than. And a solid line means all the points on the line would make the inequality true. The other thing we need to know, for any version of less than, whether it's plain less than or less than or equal to, we're going to shade under the line because we want all the points that are lower than that line. So we're going to shade our whole coordinate system underneath the line. If it's greater than or equal to, we're going to shade above the line. Any questions? It'll make more sense when you see an example. Okay, first example, what is the graph of y is greater than x minus 2? First, forget about the inequality for a minute and just think, how would you graph y equals x minus 2? Let's see. Test still, definitely not here. Kiara, what would the first point of a graph be? Go down 2, our y-intercept is negative 2, so we're going to put a point there. How about my next point? Good. Up 1, over 1. So we have a point there. And I can keep going up 1, over 1 to give myself a few more points. Now, before I actually draw the line, I need to ask myself what kind of line I'm going to draw. Am I going to draw a dashed line or a solid line? Jackie?
Dashed.
Yes. Why?
Because you gave me a warning look when I said it.
Well, you were trying to say where you had your mouth formed in the D. Why dashed? Can someone tell me why it would be dashed? Hope?
It's not greater than less than like equal to.
Right, there's no equal sign in there, so it's not going to include the line itself. So we draw a dashed line.
Yeah.
Now, am I going to shade over that line or under that line? Anthony?
Over.
Over, good. So I'm going to shade over the line, and when you shade, you can just kind of do a series of lines. Don't make it too messy. You can shade it, the whole thing, if you want to. I'm not going to up on the board here. I'm just going to kind of draw some lines. It's nice if you kind of make them go up and down, because later we're going to be graphing systems, and it's nice if you have some vertical and some horizontal so you can see where they cross. Okay, next example I want you to try, so I'm going to pause the recording.
I'll crap it on a pencil.
Okay, let's look at how we graph this. Let's see. Kyle, where am I going to place my first point?
Positive 1.
Okay, on which axis? Good.
Up and down.
Okay, where's my next point going to go?
Up 1 over 2.
Okay, so from this point, I'm going to go up 1, over 2. I'm going to do a few more, up 1, over 2.
Oh,
Okay.
19.
Carly, dashed or solid line? Good, why?
Because it has the line thing on
Good, it has the line thing, which is called what, Carly? What? What does the line mean? Equal, it's just equal. It means equal. Okay, now where am I going to shade? Emily? Under. So my shading should look like this. Okay, any questions before we move on? Okay, let's look at the next example.
Bless you.
This one is a little bit different because we only have one variable. We have x is greater than 1. So I'm going to write this as an equals again just so you can think about it. How would I graph the line x equals 1? Reagan, what would that look like?
It would just go on the line.
On which one?
Wait.
You're right, but which one?
On the x-axis.
On the x-axis, and is my line going to be vertical or horizontal?
Vertical.
Vertical, good. So I have a vertical line at x equals 1. Now, Claudia, what kind of line am I going to use?
Dash line.
Good. Dash. So I have a dashed line at x equals 1.
Pretty neat.
Now, for shading, I can't shade above or below. I need x's that are greater than 1. So Rebecca, would I shade on the right or on the left? I want x's that are greater than 1. So would I find those on the right side or on the left side? On the right side, good. So you would shade the right side. Okay, last example that we're going to do together, y is greater than or equal to 2. So thinking about the line y equals 2, Hope, what would that line look like?
Straight.
Oh, boy,
Straight
oh, boy.
where?
On the 2.
On the 2. And would it be a solid or dashed line?
Solid.
Solid, good.
Bless you.
Okay, and this one, it's still easy to do above or below. Noah, am I gonna shade above or below? Above. Okay, the next two are examples for you to try, and then you have your assignment listed there. So I'm gonna go ahead and stop this.
Yeah.